All right, we're back with part two, example two, part two, example two. And I mentioned how at some point we will be reaching for our calculator, and this is kind of like a warm-up for some of the applied questions that we'll have uh, later in the unit. And it's just practicing putting an awful expression like that into your calculator. I'm going to show you two ways, and this might take a little bit, but it'll be worth it. There's two types of calculators. Some calculators you can just type it in exactly as it appears, and that's kind of like the graphing calculator. So if I can get the graphing calculator to turn on, I'll show you how that would work. 2.3, whoops, 2.3 times 10, and the exponent button on the graphing calculator is this one, and some people have exponent buttons that look like that. And then the operation in here is a times 1.05. I don't really need those brackets since I put the time sign in there, to the exponent 3.29, and I get looks like 270,048, almost 2,748 and 48. Oh, oops, 0.48, and that's approximate. Okay, and not everyone has this type of calculator, so bear with me if you do. I'm going to use this is the built-in calculator, but it's a lot like some of the older models of calculators, and I'm going to show how this would look in here. 2.3 times, it's pretty close to the exponent. There's the to the exponent button, to the exponent 5, and then times 1.05 to the exponent 3.29. If you're worried about this, you should be writing down the calculator steps so you can reproduce that later, and hopefully that's the same number. Yeah, pretty darn close anyway. Now, if I'm going to put this awful thing into my calculator, there's a couple ways I could do it. I could change this to a fractional exponent. I could have this base to the exponent 6/5, but we should get used to figuring out how to put in roots. And one of the big things in these older model calculators, like this one, is that I have to put in the base first and the root comes second. So I'm going to show that. I'm going to use my brackets. 23 divided by 59, n bracket to the exponent 6, and then you see my nth root button. I want to do the fifth root, so I'm going to hit that button. Sometimes you have to press second function to get to that button, but that button 5. Okay, and I get 3.23ish, or 0.323. And then what does that look like on calculators that you can put it in exactly as it appears, while you can put the root in first, because the root's the first thing you see. And this feels a little bit strange, but I think it's more natural. 5, and then we need to hit our root button. And again, some people will be pressing second function. On the graphing calculators, it's under the math menu. There's the cube root there. 5 there is the nth root. You see it's a little x, and it's kind of like the 5 takes the place of that little x, and then I can put in my base, which is this terrible fraction. And who knows where we'd come up against a expression like this, but we should be able to put it into our calculator when we do find it. So, and yeah, same value. All right, so whichever type of calculator you have, practice putting these expressions into your calculator. The next question is sort of a setup for tomorrow's stuff, which is writing one number as a power of another number. So they're saying express 81 as a power of 3. That means 81 equals 3 to the exponent something. We don't know what the something is. Well, yeah, we do, because 81 is actually 3 to the exponent 4. Well, how would I get that? Well, try some. 3 times 3 is 9, times 3 is 27, times 3 is 81. And if you can't do that on your head, do it on your calculator. So then I'd write 81 is 3 to the exponent 4, and then I'm done. Similarly, I want 81 as a power of 9 equals 9 to the exponent something. Well, what is it? Well, it's 9 squared, isn't it? 9 squared is 81. Done. This one's more challenging. Equals 27 to the exponent whatever. Notice if x is 1, then the answer would be 27. But if x is 2, like 27 squared is some huge big number. 27 squared is that number, 729. It's too big. It's got to be somewhere between 1 and 2. And we got to figure out what it is. Well, the trick is both of these are powers of 3. So I can think of this expression as 3 to the exponent 4, and 27 is 3 to the exponent 3. We came across that when we were doing that up here. Let me clean that up so it looks nicer. Three to the exponent 4 equals 3 to the exponent 3 to the exponent x. That part's 81, this part's 27, but these two things have to be equal, right? So I know 4 is the same as 3x, right? Because I'm multiplying the exponents there. Divide by 3 on both sides, and then I get x is 4/3. And in fact, if I would have thought about that, I know that I have to get rid of the 3. I have to have, let me change the color here. The 3 on the bottom is going to cancel the 3 in there, and then left with the exponent 4. That makes sense that it's 4/3. So then I can write 81 is 27 to the exponent 4/3. Change my color back here. D, express 3 as a power of 81. Now this doesn't seem right either, because again, 81 to the exponent 1 is already way too high. 81 to the exponent 0 is 1. So this is going to be some sort of fraction. And that's what we're dealing with, isn't it? We're dealing with fractions. So again, I know, if I want to think about it this way, 81 is 3 to the exponent 4, isn't it? And I don't know what that exponent is going to be, so that I end up with the same exponent as 1. Well, here, what do I got? This exponent, 4x, has to be the same as 1. X is 1/4. So therefore, 3 is 81 to the exponent 1/4. And of course, yes, it is the 4th root, right? The 4th root of 81 is 3. Check it on your calculator, right? Onward. Solve d to the exponent 8 equals 120 or 1234. Well, what operation gets rid of the 8th power? D to the exponent 8, I need the 8th root. Just like if it was x squared is equal to some number. Well, how would I get rid of the squared? Well, it's the square root. Well, it's not the squared, it's the 8th root. So I need the 8th root of 1234. And again, which way do you want to put that into your calculator? Do you want to use your nth root button, or would you rather put that in as a fractional exponent? This might be the way that you'll like to do it with a fractional exponent. And how would that look like on this calculator? Well, same as the graphing calculator, 1, 2, 3, 4 to the exponent. See, to the exponent, and then in brackets I'm going to go 1 divided by 8, and I get 2.43. About. Lastly, the volume of a sphere is 950 centimeters cubed. Find the radius of the sphere to the 10th of a centimeter. Of course, I don't expect you to have that formula committed to memory. Later on, we'll do some measurement problems, and you'll review some of these formulas. But here it is, and I would give this to you on a test. It's 4 pi r cubed over 3. But we know the volume is 950. The volume is 950, and we want to find the radius. So how do we handle this? Well, it's a little bit of equation solving involving exponents. Multiply by 3, you get 2850 on that side, divide by 4 pi before we can take the cube root. So far, we've still got an exact answer. Notice when you put this into your calculator, you need to put in these roots, otherwise your calculator will mislead you. What it'll do is it'll divide by 4, then multiply by pi and give you a wrong answer. You need to divide by bracket 4 times pi and bracket equals. And I'm going to get, this is going to be an approximate answer. Probably you do all of this in one step. R cubed is about 226.8 and a bunch of change there. Then cube root of both sides. However you want to do the cube root, there's different ways on your calculator. And I would probably be okay, oops, because once we've taken the cube root, this is R. R is about 6.1, I think, centimeters. Done.